Today's daily LeetCode problem of the day is all ancestors of node indirect acrylic graph, number 2192. So for this problem, we're given a positive integer n, which represents the number of nodes in our graph, and the nodes are from 0 to n minus 1. We're also given a 2D integer array edges, so the edges are of from to 2. So return a list answer, where answer of I is the list of ancestors for the ith node. So we need to return a double list. So we're going to initialize our list. And this is going to be answer. It's going to equal a new array list. So this is basically two array lists. So this is going to be list of I is equal to another array list. And then that second array list is where we're going to put our values. Okay, and then we want to also initialize another array list, which is going to represent our graph. So array list integer graph is equal to a new array list of size n. This one's also of size n, but it's fine. So now we do a for loop to initialize both of these. So for int I is equal to 0 as long as I is less than n, I plus plus. And answer is going to dot add a new array list for each one of its ith positions. And graph is going to set graph of 1 is equal to a new array list. So that is our graph graph value. Graph of I, sorry. So then we are going to iterate through our edges. So for each, okay, so now we're going to iterate through our edges. So for each integer array called edge in edges, we're going to go to our graph and we're going to add graph of edge 0 dot add edge of 1. So this is because edge of 0 is going to be equal to our from value, and edge of 1 is going to be equal to our to value. So then after that, we are going to do a depth first search. So basically that's going to check. So basically 0 connects to 3, 0 connects to 4. So 0 connects to 3, which connects to 6, which connects to 5, and 0 connects to 4, which connects to 6. And that way, oh, and 3 also connects to 7. So that way we know that for node 7, 3 and 0 are always previous. For 6, 4, 0, and 3 and 0 are always previous. So we need to do a depth first search. So for int I is equal to 0 as long as I is less than n, I plus plus. And we can do a depth first search. We're going to give it graph. We're going to give it I, our answer, and a new Boolean variable. So we'll just call it new Boolean array, and it's going to be of length n. So let's go ahead and define this function. So private void depth first search is going to contain an array list of type integer array called graph. We're going to have an int parent, an int child, oops, and then we're going to have our list integer called answer, and then we can name our new boolean array visit. Okay, that looks right. So in our depth first search, we first want to mark that we are visiting our current node. So visit of current, or our child, is equal to true. Then we're going to want to go through our graph and determine which nodes we have visited or are going to future visit in our depth first search. So we have for int destination in our graph of current, if we have not visit a destination, then we will do answer.get destination dot add parent, because that means the parent node that we are currently on is a ancestor of whatever the next destination node that we have is. Then we could do a depth first search on our graph, parent, our new destination node, give it our answers and our visits. So that is our depth first search method. After that, we simply just need to sort our answers. So for int I is equal to 0 as long as I is less than n I plus plus, and we're going to do answer dot get I, so every position, and we're going to sort them according to their integers. We're going to compare to on them, so it should sort them in order. And then we could simply return answer. Crap. Maybe if I spelled it right. which is a lot of misspelling errors. Child. Cool. So this passes our test cases. Oh, and it passes all of our solutions. Cool.